Test, test. Audio check. Levels, levels. Oh. Testing. Check, check levels. Is this thing on? Can you hear me? Cool. Nope. Sorting out my display here. Give me a moment. All right. So I want to continue working on Squishy a bit. I should probably pull that up. Make sure the server is running. Oh. Cool, that's running. And it shattered. Oh. Yeah, it doesn't help if I kill my MySQL array. So, 85, I actually want it to die if I don't get a good connection. Handlers. Alright, so we've got this Squishy project, building a vulnerability playground, intentionally building a web application that has exploitable surfaces, and it's going to be essentially just a playground. I haven't decided fully what direction to take it. I mean, I could leave it a mystery, or we could have it be tutorial style. Maybe those will be selectable modes. But for now, I just want to get something wired up, and right now we've got this database squishy. And it's wired up to this very simple little dingus here. I don't like that Safari hides the URL. I kind of get what they're going for, but for my purposes, that's not awesome. I wonder if Chrome will do the same thing. No. 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 What port are we on here? 8080. Cool, our auth page, that looks awesome. App. Oh, requires that. Okay, maybe it's worth wiring up off. The noise from the clock. I don't think does the clock make noise? Clock shouldn't make noise. Really? The clock isn't designed to produce any noise, so I'm not sure why it would. And I think my clock just broke. I think it just broke. Well, that's not fun. So the noise you might be hearing could be my ceiling fan. I don't know, you tell me. My MacBook Pro is also getting a workout. Let's do this. Get rid of the clock. Now you tell me what you hear. Maybe the noise floor on the mic is too high. Are you getting noises when I switch applications? Is it just a hissing sound? What are you hearing? Is it when I switch applications or some other time? Yeah, I'm not sure what's causing it either. Is my audio better at the moment? Alright. I'll carry on. So I don't want any of this at all. Bye. Alright. I guess we'll do a login authentication. Is the audio still okay? Alright, we'll go ahead and try that. So I got a login, an app, I've got users. Nope. What is MD5? 64? Or no, I'm not going to use MD5. I'm going to use SHA-256. We'll figure it out here. Edit. May not be null. What are you complaining about? Oh, because I've already got no discard. Yeah, I already have null in here. Delete. Delete. Don't allow null. Yeah, empty. Okay. So we're going to log in. Where's my login screen? And I don't think this form currently does anything. Let's see, how do I want to handle that? I want to go and send it to an authentication path. Router dot post. that's all going to end up moving, but that's fine for now. And then what I'm basically going to do is I'm going to have it post the form to this authentication handler, and this is going to send it back a 200 like HTTP status okay, and a meta tag that'll cause it to refresh to the correct destination. Maybe we can do a 503. Not 503. 303? We'll figure it out. So this is all going to be in the request. Parse form. In Go, when we get a request from an HTTP request, first thing we need to do is tell the request to parse the form. And then what we have is we've got like a username and password variables we're going to pass it. So we can go say user is going to be get user and pass get pass. So we want to make sure that we're posting a user and a pass. Should I just make these username and password? Why not? So we need a form whose action is going to be to go to that login or that authentication page, which will redirect it. Squishy, so we have our form start here. I'm going to have to remember, I don't actually remember HTTP or HTML forms that well, so I got to look this up. I don't like W3 schools, but it'll do. Method get action is the destination. Action is going to be, what did I say, auth? I think I said auth. Right. Input text, placeholder, name is username, name is password. So the form's all kind of ready to go. I just don't have it wrapped in a form element. Nesting things manually because I'm not using anything that makes it nicer and happier by itself. I don't know why I've got all that extra stuff. Like, what's this for? I don't know. Probably isn't necessary. Let's test that theory while I'm in the middle of doing something else. Just comment these out. Oop. Well, it's probably a smarter way to do that. Yeah. I did purchase Sublime. I'm just not buying it for my same computer again. And I haven't decided what to do about that, if anything. Very quiet. All right. Turning up the heat on the mic. Let me know. I can bring it up even a little bit more there. Oh, am I dropping frames? A little bit. Okay. A bit more. Turn up the master mix. How's that? Is that alright? Shall we... I mean, looks pretty hot on my levels now. Is your TV turned down? I'll continue. Okay, if you say so. Turn up my gain a bit. How's that? Even more? That's pushing well into the yellow on my meter. Alright, I'll carry on. Cool, thank you. Alright, we're going to do a post off. Where's my submit button? It's probably also on me because I'm not talking very loud. Awesome. The ticking noise. Yeah, I see something showing up on my meter. I'm not sure what that is. Let me try adjusting gain here a little bit. Try pull the power from somewhere else. Yikers, that looks possibly worse. But you tell me. Do we fix it? It just got worse? Okay. That might mean my USB interface sucks. Testing 1, 2. I got a very low noise floor now. Working on it. Nice. Okay, cool. This audio stuff is trickier than I imagined. Not my expertise. Nice. Oh, is that Dad? Hey, Dad. Alright, carrying on. I need a submit button wired up. This, I think, is the button I want to use, but that's currently type submit. That should just work. Alright. Mic down, physically down. Well, I was told I was too quiet and I turned it up. Do what I can. Alright, I just brought it down a bit. You just keep letting me know, give me feedback. Alright. Yeah, clipping. I've got this USB interface that I think I've decided is basically garbage. Anyways, whatever. I'll figure it out later. Alright, I want to wire up my login page. And when I go blah and blah, oh, I gotta put this path into use. User 5 requested app. Alright, let's do a little bit of logging here. Let's just say log.printf user requested authentication with password. Let's wrap those in quotes so we know if we get a blank. And just let it log and do nothing. w.write w.header set. Do I want to do a meta refresh or do I want to, let's see, there's probably a standard. Redirect after log on. Stack Overflow. Login redirect. I don't care about WordPress. Auth 0, it seems more like a standard spotty type of thing. Redirect URI. Oh, this is for third-party auth. I don't care about that. Maybe it doesn't matter. Maybe you just need to pick one. 301. Is that a HTTP header? Location header. Okay. Yeah. Dot set. And then I'm just going to automatically redirect us to the app just for now. Just do that. See if that works. Nice. Yeah, I called her as well. Having about as fancy a birthday as you can achieve given coronavirus complications. Yeah, alright, so I'm not using that stuff because I didn't finish that line. Cool. ASDF, that. And it sent me to auth and didn't redirect me any further. User ASDF requested authentication with password ASDF. Good. Okay. So why w header set w.header.write to w? That doesn't seem like it should be necessary. Well, that clearly didn't work. W dot right header HTTP dot status redirect. request. Move permanently. I don't think I need this. That seems silly. I don't want that either. Inspect. Give me my Chrome debugger. Go back. Console. Put this thing at the right place, please. Network. Preserve log. Clear all that stuff. I need to turn off auto. Yeah, so what this is, I'm building a playground in which one can explore vulnerabilities. This is going to have vulnerabilities baked into it, anything I can think of, and I'm considering having it operate on multiple modes. Oh, it looks like I got raided by my guy Harrison. Thank you, my guy Harrison. That was cool. So I think what I'm going to do is I'm going to have this potentially work in multiple modes. What I want to do is expose people to what an actual exploit looks like, whether you're a developer or an end user. And so what I'm kind of aiming for is like a turnkey thing somebody can bring up on their computer. They can download a thing, double click on something, and have an exploitable application. I know that sounds awful, but I'm aiming for like localhost only. An exploitable application that they can then try to break, try to make it misbehave, and just see what this stuff looks like in the wild. And it's really a teaching tool. And then for a developer, you can see how do these things manifest themselves. When you have a vulnerability, how can this appear in logs? And then how do you patch for that? And some of this stuff is going to be kind of painfully obvious. We're going to have like some SQL injection. I'm working right now on the basic functionality to get logged in and have something to poke at. And we're going to do some really poor session handling, and authentication is kind of going to be a joke. But then I think one of the obvious ways to show this improve is we have maybe they're branches in GitHub, maybe they're modes in the application. I'm not sure yet. But take it from, kind of crappy joke style authentication to, effective authentication, effective session handling, and then take it a step further to using multi-factor authentication, and what that looks like and how that presents it to the developer, and how that changes the interaction for the user. I think most people are probably familiar with multi-factor at this point, but we can tell kind of the whole security story, soup to nuts, and you can get a good idea of like, okay, these things that I've heard of, like multi-factor, are a thing. And what are they? Why are they important? There's a history and there's reasons these things exist. Some people just take them for granted. Some people say, like, this is the way you're supposed to write this, and don't worry about the implications or the reason behind it. I mean, that's okay if that's the way you want to learn and that's all you want to learn. I'm always curious about the underlying reason. There's generally some interesting story some exploit that existed. Somebody got hurt. Somebody lost some blood and ended up changing some technology, and now everybody uses this or that standard. So that's kind of what I want to explore with this application. Try to adjust my sitting position if it's too hot on the mic. This microphone's also not super easy to work with, I'm finding. I think I need a different style of mic. Sure, you ask me a question, get me talking, and then, hey, you're too hot on the mic. All right. I want to get this working. What was I doing? Oh, yeah. We're going to simulate. It's not going to simulate. We're going to do an authentication attempt and see what we get back. So we get a white page. We're getting something from auth. I don't want that. I want it to redirect me to the app page. Location, app 5. Status moved permanently. I don't think I'm getting that. Response, headers, moved permanently. I don't see a response header. Am I doing that wrong? Am I doing this out of order? Close that. Out of order. Go is a bit finicky with the HTTP handler. And I mean, they abide by the spec of HTTP, I'm sure. I haven't read it, so I couldn't say. I've seen where if you write the header, I'm pretty sure when you write header, that's basically like final nail in the coffin. You don't get to do anything else. You don't get to write any more data to your client. So you need to write the stuff you want to write first, and then write your header. And so we got the action we were looking for. Brought us right to the application. And this 5 in the URL bar is actually the user's ID, which is doesn't exist. Work assignments. And then if I reload, because we're so loosey-goosey here, work order assignments were still assigned and still visible because, yeah, okay, that's fine. Okay, but that's not actually login, right? That's not an actual authentication. So now we also need a way to break the session, break the, well, we don't have a session. So we're going to claim that we're breaking this. I gotta send it a cookie and tell it. I gotta record the cookie and tell it that it's there. Yeah. Really crappy session handling 101. Alright, so let's do logout handler. Auth handler. I don't like typing all this garbage out. Sure. We can call it that. What we might do is just hold on to them in memory, which is really lousy. and then you can effectively log people out by restarting the server. But maybe we'll put it in the database. Probably will. So I just want to get for log out. No, just that. Okay, we'll do database session stuff. Fine. Gonna break. This is what's called a migration, a schema migration, because I'm changing the database. And now if I restart the server, everything will shatter because I've restarted or I've changed the name of the table in the database where my users are. Although, do I even have? I don't even use it. Well, there you go. Of course, we don't have a whole lot of any, database access code going on. So my background and motivation for this thing, I am a developer at a third-party IT consulting company, and I build tools. And my background is in Go and back in the day PHP. And so I spend a lot of time working on systems and solutions and tools for the IT industry, and specifically for the multi-tenant third-party IT consulting industry, where we don't have just one company that we're doing IT for. We've got hundreds of companies that we're doing IT for, and tens of thousands of endpoints that we're managing and monitoring. And so part of my job is to build software that allows us to scale with fewer people than if all of those companies had their own IT talent. And so fleet management is kind of the name of the game. Automate all the things. And what I'm building started as an idea for a way to give people a foot in the door with their security understanding. And it kind of morphed into, I was going to be giving a talk on effectively security and vulnerabilities at Tech Pulse, an event that my employer puts on in April. As you might imagine, a conference in April isn't going to work because of coronavirus. So that has been canceled. But I'm going to continue working on this little toy and building it to do what I wanted. And we also work on these concepts during Code After Dark, which is a thing that we were doing for the last couple of years at work. And it was just a teaching opportunity, get people in the same room to, kind of put heads together and questions about programming in general, and just trying to level up the techs. And sometimes we would talk about PowerShell or shell scripts or the scripting languages that exist in the tools that we already have, etc. But this has become a more generalized thing, and so now I'm just broadcasting the production of Squishy because it's a project I can work on that's got some direction, and I think it's kind of interesting. I am by no means a security expert. I do not have any of the background. Most of the people that are watching have in security. I'm an application developer and probably not a great application developer. My real strength is in tooling and automation of Windows, Linux, and Mac systems, and making tools that work across those things. I'm basically trying to make an interface that our techs can perform various tasks, anything from like a password reset to like a WAN speed test, whatever, at scale, like lots and lots of endpoints, lots and lots of companies. And so, again, this is just a vulnerability playground. It's kind of going to be the kitchen sink mentality. There's going to be SQL injection. Right now we're working on really bad session handling. So like in the URL here, you see this integer, this number 5. That is actually the stand-in for this user. And because the security on this application sucks, you can just type 4 in there, hit enter, and see how the content changed? Yeah, that's because you're actually impersonating a different user. And that's not okay. But that's the point. So I'm working right now on getting the authentication wired up and trying to intentionally misstep and not do it correctly. And I feel like I'm falling into doing it the correct way, so I'm having to go a little bit more slowly, because I think we need to have some session handling, but I don't want it to be so good that we can't jump it between users. The whole story for this originally for my talk was going to be, there's a whole bunch of business owners sitting in a room, and I'm talking to them as business owners, not tech people. And I wanted to show them what it looked like when a vulnerability exists and how it looks like it when it can be exploited. And I think it's difficult to get most of those people, big brain business people, to get into like the development console and look at anything. But I think you can have them look at the URL, and that's simple enough to understand. Like, it's a place where you type stuff in and you know that facebook.com shows up there and that it means something. And so they've seen garbage in here, and they see like the little padlock that tells them they're secure when maybe they're not, that kind of stuff. So what I want to do is indicate to them, look, this thing right here is a thing that can change. It stands for the user you are. And so let's imagine you have some internally developed app developed by somebody that maybe doesn't know how to build secure apps. Whatever the case may be. Well, they've got in the URL bar here this number, and one of your users that's working on work orders decides that they don't want to have all this work lined up to do, so they are going to go and snoop around and see what that number does if they change it. And so the story is they change it to a different user, and they discover that the controls are different. And because each user has different permissions, you'll get management interface, for example, that'll show up, and you'll be able to change the assignment of work orders. Previously not possible because your actual user doesn't have those rights. But because you can jump users, now you can change this stuff. And so as a business owner, you go, oh, okay, so that's like a hack. Yeah. So they were able to hack the system, essentially, log in and impersonate someone else, and control the system in a way they're not supposed to be able to control it. But then the problem arises, well, we've got logs, right? And so we know when management orders or work orders are assigned and when they're created. Well, we're going to have a dev mode, management, what have you, where the actual logs are editable. Also not a great idea. But in this app, it's going to be a thing. And so the end user is going to be able to hop to like user 0, which would be developer, and this, extra logging stuff would be visible. And they'd be able to modify the logs such that it looks like when the work order was assigned originally, it was assigned to whoever they decided to reassign it to. And so they completely cover their tracks. And now this person doesn't have to do as much work. And that's the basic story for a really simple vulnerability that gets exploited. And, the other side of this was I was going to talk about the patching story. What does this look like when a developer gets a bug report from the management saying, hey, we've got all these work orders being assigned to people, and strangely there's like this one user, or maybe there's a couple of users, maybe there's secret spreads, maybe there's a couple users that have less work than I thought I assigned to them, but everything says I assigned it to somebody else. I don't understand what's happening. And they're kind of starting to lose their minds a little bit. And maybe they even start tracking it separately on like a notebook. And so they start realizing something's wrong. There's a bug. We're not sure what's going on, but these people don't have the work we expected them to have. And so the developer has to go and add some more logging, and eventually, you see the smoke and you can figure out that the users are going in and changing stuff after the fact and changing the logs in addition to changing the work orders. And then somebody has to have an uncomfortable conversation. But that's a complete story for a business owner sitting in a conference to hear, to see how it's exploited, understand that there's like this need for extra security, et cetera, and that these are real problems that people identify and take advantage of, and they become far nastier in other ways. That's just the initial story of Squishy, and we're gonna do some other stuff, fun stuff with like right now I've got some SQL queries going on in here, and we're gonna do mostly this style. You see this question mark in here. Go has built into it some parameterized database querying. So when I do a database query here, I pass it this Q for query, which is just a string, and then I pass it additional arguments that are going to have a one-to-one replacement of the question marks. And it does so in an intelligent way. So in MySQL, you could have user ID be the number 4, or you could have it be 4 in quotes. But if the field here, user ID, was some other thing like a name, Bob, you can't just have Bob sit there. You have to quote Bob. And so you got to wrap Bob in quotes, single quotes, double quotes, whatever works. In this case, if we were to do double quotes, we'd have a problem because we're actually encasing this entire string in single quotes, so you can see it's escaping, or the double quotes, it's escaping the double quotes here. And so you actually have to escape the double quotes so that it works. So that's a escaping quotes inside of quotes 101. But since that's a pain in the butt, we just do blah, and Go knows to add quotes to the argument, and it just does it. I guess I'll real quick. I know a couple people are watching that haven't seen what a SQL injection attack looks like. We'll do it with we'll do a bad one with the authentication here. So you can see we've got username and password, and that's being passed into us eventually here. And I'm going to bring this up again and show. Here's our network requests. I'm going to log in, and you're going to see auth. And here's the request form data. Here's our form data. Username and password were passed in. right? So the fields for username and password turn into this form data, and that's what it looks like actually when it's passed in over the wire. And this is just the prettified version. And then we catch this on auth handler, right? So it's going to auth, right? Auth is handled here, this path. We say if it's a post to auth, send it to auth handler. Auth handler's in here. Here's auth handler. And this is typical Go style HTTP handling. And this is actually extra crap. So we're going to ignore that for just a moment. Usually in Go you have HTTP response writer and an HTTP request. The request contains all of the information that was passed to you, username, password, the data from a photo, whatever. There's a request sent to the from the browser to the server, and that's what's in here. W here, this response writer, is the thing that allows us to talk back to the client. I'm using this HTTP router thing, which is a really nice way of handling paths. So like /auth /wo for work order. And then it's got this : WOID, work order ID. And this little syntax sweetness here is enabled by this HTTP router package that Julian Schmidt made open source. And I'm using that to make my paths simpler. And so that post comes in here, and here you can see we're posting now. This could also technically handle a get, put, there's other HTTP verbs. Get and post are the most common by far. Anyways, we are here. Request is fetching this data for us from the client. We say parse form, which tells Go to take the data that was sent to Go, to the server, parse it, and then it populates this form field of request. Request is what they call in Go a struct. A struct having a number of form fields. I'm sorry, the struct has a number of fields. Form is a field on this thing which has in itself some magic. And what it allows us to do is say get username. So it finds the variable called username, which is defined here when we pass it in, as well as password. And we've got those variables here and available to us. And that's why when it says user blah, requested authentication with password blah, our log shows user ASDFC requested authentication with password ASDF. So now we get to decide what to do with that. Right now we're not doing squat with it, and we're just saying redirect to /app/5 and just send it http.statusMovePermanently, which is a 301 redirect, which is the lightest weight way to make the browser go to the thing that I want, which is the now authenticated session for that user. So what we want to do, first off, we got to fix the problem. Our users, they don't have password hashes. Also, this is going to be a vulnerability playground and like an example of a crappy app, but we're not going to do the crappiest thing, which is storing passwords in plain text. That's not going to happen. That's just completely unacceptable. If anybody doesn't do that properly, they got problems. And you can identify if somebody is storing your password in clear text in their database because you can ask for it. Say, hey, what was my password? You tell it, send me my password via email or something for a password reset. Some of them will just send you your password. That's a good sign that they have your password in plain text in their database. That's bad. If they don't know what your password is, so they just reset it to something and send that to you, is pass hash equals salting. So we're going to step right through that right now. I'm going to show you exactly. You're not wrong, but you're not 100% right. So hashing is a concept whereby, let's just do a blah 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 right here. SHA 256 dot new. I want some, and I'm going to send it password. And this is going to give me password hashed. Some 256 is going to give me a 32 byte. So let's say password this and hash. Now let's restart the server. Because now it can. Did it die? Cannot use password type string as type. Okay, we have to cast this. This is currently a string. So I'm going to cast this to a slice of byte. Now it's happy. Alright, I want to go here, and I want to go back. So now it's going to hash the password. And here you can see that is the decimal representation of the bytes from the hash. So each byte is represented in each number here. And a bunch of these are going to actually be letters and numbers in ASCII, but a bunch of them are not. So what we want to do is we want to take this and we want to go base 64 dot standard encoding dot there we go, encode string, encode to string, yes, and then we're going to give it this pass hashed. We have to do this notation here because this is actually an array and it has a specific size, and actually this thing wants bytes, a slice of bytes. See this? Not really worth getting into the mechanics of what that means, but it means we have to do some funny stuff. Pass hashed B64. So now I can say and that is going to be a string, and that is going to work like this. There we go. User ASDFC requested authentication with password ASDF and hash this garbage. That's what we want to see. And I don't want that to be base 64. What do I want that to be? Hex. I want that to be hex. Let's see. Because I want to store that as hex. Hex dot encode to string. Same thing. Yep. And the variables that I'm using could be named whatever I want. Just using them because it's kind of obvious to me at the moment. So at this point, to answer your question, we have not used salt yet. We have just hashed. Go back. Look at our log. There we go. That's what I want to see. So that is the hexadecimal representation of the SHA-256 hash of ASDF. And we're going to get a similar kind of output for really long text. Same number of characters in this hash. And that's like, what? Probably 128. I probably did the math wrong. 64 characters. No, I did that right. Cancel. Don't save. I did 64, right? Structure? 64, yeah. Okay. So, if all I did was hash the password and stored the hash, that's not in and of itself a sin. That's not that big of a deal. If I was the only person doing this in the universe, wouldn't really make a difference. However, there's lots of other applications, lots of other vendors, lots of other websites, and they're also hashing stuff. And the problem is that the hash of the word or the password dog or password, let's just use that, the hash of the string password is the same between two different vendors if they don't use salt. And so if your password gets leaked, if the database gets leaked of usernames and password hashes, if you use the same password at two different websites that don't salt their passwords, they can tell right away, and they can just reuse whatever they can generate. They can generate that hash, or they figure out your password and then use that, and they know that they can use it at any of these other places that have the same hash for that string. So the way you avoid this is adding salt. And so here we've got this password hashed, and all we have to do to salt this is add something different, something that's going to theoretically be unique to us, and ideally something that's going to be unique to this user. And a noob way that I've done this in the past is to use the username's hash as salt for the password hash. Problem is, if the username can change, you run into issues, because then your username changes, which means your salt changes, which means your password is now invalidated by changing the username. That's not cool. So it's possible to just use any kind of text, anything, to change up the hash that is created by your application for the purposes of storing the password in the database. And so this would create a completely different hash that now is completely, theoretically unique to my application, as long as no other application out there is hashing with the salt elephant. And it's better yet if you use some user-based hash salt. Yeah. Thanks, Christian. So storing the salt in the database. Well, if you store the salt in the database, Christian, does that not have implications for the leaking of the database as well? So the database gets leaked, the username is there, and the hash The point is to make pre-computation attacks impractical. Right. Okay. So are you generating some salt randomly per user and then storing that with the user record? Right. So does the level of entropy on that matter? Does it matter if it's a pin versus a 30 character passphrase of some kind that's randomly generated? Make any difference? So he's arguing, essentially. Let's see. Let's do this. So I'm gonna bring in the rand package random, and I have to seed it so that we get actually random values. Otherwise, every time you call random, you get deterministic values. So like the first time you call it for like give me a number between 1 and 10, it'll give you a predictable number the first, second, third time. As many times as you care to remember, you reset, you go back, you do it again, and it follows the same pattern. You do this, and it eliminates that determinism. The longer it is, the less likely there's a pre-computed table for it. Because you could pre-compute the hashes of every 8-character password, but then continue to pre-compute the same hashes with every ASCII character salt, then every 2-character combination, then keep going. Right. It's far less likely that someone has tried to pre-compute hashes for a 20-character salt, but that's probably excessive. Okay. But, I mean, for us, storage-wise and computationally, like 20 characters, 40 characters, 80 characters kind of doesn't matter. So you just make it harder to, or less convenient, less feasible. It doesn't matter. You think it's that diminishing of returns? Okay. So it could be argued that one version of this application could have the example authentication method whereby the password isn't salted. But that's not going to be that interesting to look at. Just don't use the one that's stupidly short. Sure. Okay. So we'll just do some random generation here. And what do I want to do? I want to do... we'll just make a quick little... string generator here. And I want... probably done this too many times. There's an easier way to do this. There's a fancier way to do this. I'm not going to remember it off the top of my head. Don't paste the code into chat, Christian. It's not a race. Alright, so I want to get a random character for each of the length. So for given length, so say 8. For each of those positions, I want a random character. So I'm going to give myself some number of characters to play with. I can't do it without mumbling the song in my head. Yeah. So that's shorthand way to get 26 times 2. It's 50 some numbers. 52. Yeah. So I want to do rand int 31n. And basically what it's going to give me is a random number between 0 and n. N, in this case, being the length of chars minus 1. Because chars will be 52, but the actual highest number I want is going to be 51 because it's a 0 indexed. I don't want my loop there. B dot right straight. I believe that ought to do what I want. So what this thing's doing is it's creating a list of letters, both uppercase, as you see here, and then I'm going to take that same thing, this variable, feed it back into the toLower function. Is going to turn all those into lowercase and concatenate it with the original set. So I got A through Z capital, A through Z lowercase. And then I'm creating a string builder, which I will then use when I loop over the length here. This is wrong. So I'm starting at 0 for the index, and as long as the index is less than the length, I'm going to continue to loop. And the index here I'm setting to, the index of the char's position I'm setting in here. Do I use I in here? No. So I'm getting a random index with int 31n, and then saying write a string to the string builder with one of the characters indexed with this random number that I just created. And then when we're all done, when we've hit the maximum length, it'll eject from that for loop, and we will return this string. The string is going to be used here. We're going to use this incorrectly initially because I don't have a user creation mechanism at this point, but that's what we're going to end up doing is have some user creation mechanism, and then when you create a user, it's going to assign them a salt, and when their password is created, it'll use that salt. But for now, we're just going to do this. Salt rand string generator, and I'm going to do 10. And then we're going to see what the salt was that it decided to use. Oh yeah, length is a reserved word. I'm going to use line characters, type int is type int 32. Okay. Do the thing. Where did that? Thank you. Type byte. So to recast this, since it's looking for an index inside of a string, it returns a byte instead of a string. I guess I could actually be a little bit more optimal and say write byte. Okay, stood up the server. And look at our log. Authenticated with password ASTF with salt, and just gave me that, and hash that massacre. Thanks for the help, Christian. So that's the probably most correct way to handle password storage. We, of course, haven't stored it. So let's go ahead and do a user create function. And we're going to need a username, password, and I think that's all we're going to need. So basically take all of this stuff and reuse it up here. result. Replace that. Okay, can I find it? There it is. And print the error if we get one. Looks correct. Tighten that up a little bit. Alright, so what I want to do is I want the next time I launch this thing, I want it to just create the first 10 users. So we're going to have it do that. After it's got the database open, before we've created the HTTP server. User create, and let's do I'm going to create 5 users. Not at all what I want. String. How come I'm using the wrong key? That'll do. And those are the wrong characters to use for a string literal. Slice a string literal. And I'm just going to create them with the same password as their username for now. Alright, let's go see if this will start. I'm going to call them username. What do we call it? Name. Let's go check our database. Boom. We have salted passwords. So now I'm going to go and comment out this. Actually, I'll just delete it. Don't care about it. Well, yeah, we don't care about it. Now what we want to do is we want to see if authentication actually works for those users. So now what we want is to see if we can select that user using that username and password that is now a salted hash, and get the ID out, then we proceed on to the app. If we don't, then they get kicked back to the login screen and we don't tell them anything. Or in this case, maybe we give them hints like you've tried logging on however many times, or user blah doesn't exist because, side channel leakage is bad and this app's going to behave badly. And it's also where I can try to do some really crappy SQL injection. That's what I want. And I'm going to get the user ID. Posture must be goofed up here. Holding control or option instead of shift. If user ID is greater than 0, yay. This is where we're going to do our thing, and we're actually going to do one extra bit here. We're going to create a string here, but instead of that, we're going to use our actual user ID. And that's how we close that up. Otherwise, we're going to say w.write header. We're going to write forbidden, locked, okay, failed, forbidden, 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 for now. And we'll redirect them back to slash. Don't do that. Don't do any of those things. To slash. Yeah, I think that's what I want to do. All right. Database is populated with users. Query row. Scan returns one value. Well, first off, I didn't even scan in user ID. Two variables, but does scan returns one value. So it only returns the error. Yep. Quit holding down the wrong button. Thank you. Define dest. Yeah, I know. Okay. And our code to create our users is gone. Code to authenticate exists. And now we are theoretically testing our authentication with actual users. So Bob's password is Bob. I'm going to try SDF. That's a very unhelpful thing. I wanted to not fail. So maybe we won't write forbidden. And we're getting an error from SQL, no row in result set. That's because it was the wrong password. Bob with ASDF again. I'm going to clear the log. Also not helpful. So maybe we need to do this again. Okay. That basically did what I wanted, although I'm not sure I want to do it that way, but it'll work. Let's see if authentication actually works. Gotta kill that autofill. No rows in result set. Why? Oh, I'm generating the salt. I don't want to generate the salt. I want to go get the salt for that user. So I've got the salt stored in the database. I guess I have to go fetch the salt for the user that we're trying to log in as, apply the salt to their password, and see if the result is what we want. I don't really like doing a round trip to the database for salt that might not be the right password, but it'd be lovely if I could type correctly. Yeah, I know. And that's actually, if that fails, yeah, that's fine. If we fail to get this salt because the user doesn't exist, we'll just send it back to root, and it'll look like it failed to log in. I think I'm fine with that. Undefined salt 64. Yeah, I mean, yeah. All right, now let's try logging in as Bob. User ID 1. No work assigned. Should be able to jump up to user ID 4. We got data 5. We got different data. Is there a way to have the database perform both operations at the same time to avoid a round trip? Instead of fetch salt, hash with salt, get salted hash, compare, there may be a way to query with username and password and have the query itself concatenate it with the salt and hash it to do the comparison. I'm not sure what function you have available in the DB. I don't want to do any compute in the database, none. So that's even less acceptable to me than doing a round trip for the salt. In production, what I would do personally is when the application server starts up, it would simply grab all of the usernames in salt and hold them in memory. If it was really that important to me, it's really not that important to me. Ultimately, I can live with doing a salt lookup anytime somebody logs in, and if you have a very, very login heavy application, you probably have to consider the implications of those round trips. It just isn't that important to me. But it is important to me to keep computation out of the database. I'm 100% against that. Databases for data storage. That's also very Microsoft SQL developer sort of mentality. I see that a lot in production Microsoft SQL databases. Lots of, this is like a key reason why I believe why SharePoint is such goddamn garbage. I believe a fair amount of compute occurs in the database for SharePoint. There's all kinds of application logic that happens in there, and I'm just not okay with it. You got application servers and programming languages that are specifically built to handle that stuff. Database should be for data. So no. And here we have user 1 requested app, user 4 requested app, user 5 requested app. So we've got authentication. We are successful in doing that. What we are not doing right now is we're not doing anything by way of checking that we're authenticated. So like I can just not log in. I can just go straight to /app/5 or /app/1 and it'll work. That's because we're not checking for an authentication cookie and then checking that cookie to see if it matches a session in our database, which is the next step. So let's see if we can mash together session. Probably a nice UUID dingus that I should use. So if user ID is greater than 0, it's logged in successfully. I want to generate do that and pass it back to the browser. I don't think I've got a UUID thing. Let's see, I think there was a nice Golang UUID. Yeah, it's from Google. From Google even. So we'll do that, we'll go get that. And then we go up here and we go where to go? Down. Interesting. New. Looks like that package has got more to it than I thought. Go doc documentation. New. So that's all I really need to do. And then a UUID is 16 bytes. And it has a string method. Cool. We'll just do that. And I already created it, I think. Yeah. So I'm going to give it the user ID, UUID, and then when I go to check authentication, I'm going to say what cookie they have, and I can check against the sessions table to see if the timestamp is in the last 24 hours or 8 hours or whatever I want to do. All right. And then I'm going to add another w.write, w.header. It occurs to me I don't know how to set a cookie. I don't think I do. Okay, that's easy enough. Time now to add date. Time.now dot eight-hour session ought to be good enough for anybody. Name value expires. So what this will also do is allow us, we're not going to do it, but it'll allow us to see if this user is allowed to access a particular resource. But, of course, we're not going to check for that. And then set cookie throws an error. Does it not? But it wants a pointer. I'm going to do the wrong password. Getting not much of anything. I don't see a session. Why not? User blank logged in. Error 1406 data too long for column UUID. Oh. Was that, did I misinterpret how long that was? $16. Hooray. But string returns something longer than 16. Alright. 36 it is. Try again. User logged in successfully, but I didn't see who that was. Printf. So now we should also have this cookie response from 1. Or no, from auth. Set cookie, session ID equals, expires. Cool. Awesome. So good. Probably don't need this extra ID column, but so now we've got successfully implemented users exist. Passwords are salted. Salt is stored in the database. We can't log in as a user that doesn't exist. Well, unless we just bypass the login screen altogether. We haven't actually implemented checking of auth. The session is stored in the database, and we've got a cookie. We could create a log out that would destroy the cookie or destroy the session and require re-authentication. I think what I might do is I might do auth checking and just make sure that that works to see if a session ID is set and valid when we go to the app. So when we go to app, we are passing it, yeah, cookie session ID, blah. So I want to say cookie. How come? How come? No, go down. Thank you. Oh, it returns a pointer to a cookie and an error. Got it. I think those will be the last thing I implement today. I'm getting hungry, and I've achieved most of the login logic that I'd hoped to today. So if there's any other burning questions, let me know. Log.print, and then I'm going to return. Select ID from So this is where I'm starting to fall into good habits. So this is actually going to check to see if the session cookie and the user ID coexist on one row, which will be broken if I try to exploit the app. So we're not actually going to do that. I just want to check if the session exists. No, I don't even want to do that because I want to be able to log in as a user that is not authenticated. I just want to see if, I'll just see if the session exists, and not actually try to pin it to a user. And that way we can be impersonating a user and it doesn't matter. What I really want actually here is I don't even care to scan it. Query rows. Query is gonna give me what I want. I don't actually care about the value. I just want an error if there's no rows. And then I actually want to treat it like a logout. Where'd that go? There. So if we have no session, we try to access the app, it'll log session missing, redirect us back to login. Cool. That's what I want. DB query returns 2. Don't care about that one. Alright. So I'm going to go in here and kill off this session. I think I might be asking for it with, yeah, I got a session ID, so that doesn't matter. And then we're going to go to /app/1. User1 requested app. That well, that worked way too well, and should have broken. /app/1. Session ID doesn't exist. Did not say session missing, so it must not have had no rows returned. So I must not have thrown an error. Query row. .scan. And I'll take that ID. Don't think I care about it, but I'll take it. And scan error. No, I don't want to do that. That's janky. Alright, let's just see. I don't think it's going to throw a different error. I don't think it's going to do anything different. It did. Okay. It's probably on the scan. That's what... it's interesting, the scan through error no rows. Okay. Well, I think I'm going to commit this, and I'm going to sign off for now. I want to say thanks again to my guy Harrison with the raid. That was sweet. That was my first raid. And thanks for the follows from Isperon Demonova. I guess that was a couple days back. And 3 bells. I'm hoping to be streaming a couple of times a week. Thursday was our customary Code After Dark night, and we might have some more of my coworkers in here around then. And then I want to do a squishy or other project-oriented stream. And for anybody interested in following along or playing along, this is open source. It is up on GitHub at github.com/codeafterdarkness, because Code After Dark was taken. Code After Darkness, and you'll find the squishy repo in there. And you can go in there. You can start up. You need to get Go installed, which is very easy to do. Golang.org will help you to do that. That's also free and open source. And you can play around with it and maybe make it look better, do cooler things. I'm definitely open to pull requests. And just keep making a neat educational tool for people. In the meantime, I'm learning right along with you. So thanks again for watching. I'll catch you guys later.